That's so funny. Hi, it's Miss Hall.
Ms. Nelson. And today we are going to be doing notes over surface area using nets. Okay, so this kind of leads into what we did over the past several weeks of our two-dimensional shapes. We're still using those two-dimensional shapes, but now we are combining them to make a 3D shape. So let's start with our first example. It says a company designed a new cereal box that is 11 inches tall, 2 inches deep, and 8 inches wide. How much cardboard is needed to make the box? So if you see over here on the left side, okay, this is what your box is going to look like whenever it's all put together. And it says, notice how the measurements on the net relate to the 3D image. So over here on the right side in our net, and net means that you just unfold the 3D shape and make it flat, okay? You see that we still have our dimensions of 2, 8, and 11, but they may be in a slightly different spot. So what we're going to do first, we are going to color code the rectangles that have the same area, okay? So what that means is, on most shapes, whenever you undo a net, most of them are going to have a partner or more that are going to be the same shape as long as they are the pieces and not the base. So I'm just going to color code. So the left side I'm going to do in one color, and it's going to be the same shape as the right side. I have the top, and it's the same as the bottom. And then I have my big piece in the middle. That's the front, and it's going to be the same as the back. Okay, so we have 3 colors. So what do you notice? So I have 2 rectangles of each color. That's what I notice. Meaning that I have 2 pieces that are going to be the same area whenever we work it. So it's asking us the amount of cardboard needed to make the box total and lateral. So there is a difference between total surface area and lateral surface area. So I'm going to tell you what the difference between them are. So lateral is going to be all sides. Okay, just the sides. For total, it's going to be sides plus the bases. Sometimes you're going to have 1 base, sometimes you're going to have 2 bases depending on what shape you're dealing with. So if we are making this cereal box here, and we want to know how much cardboard is needed, then we are going to need total surface area. And the reason because is, if you don't have the bases, you're not going to have a top and a bottom to keep your cereal bag in the cereal box. If you put the bag in, it's just going to fall right back out because there's nothing to hold it. So our Y is because you need bases to hold the cereal. Okay, so to solve this, okay, so now we're going to go back to the shapes that we did from the past couple weeks. So I'm going to have 3 rectangles. Okay, I'm going to have my green rectangle here, my red rectangle, and then I have my blue rectangle. Okay, and I'll switch colors and work on the color we're dealing with. So I know for my green, first of all, I know I have 2 of them. Okay, and I know they're rectangles, so area is based on height, but then I'm going to bring in the times 2. I'm bringing in the times 2 because I have 2 sides, they're going to be exactly the same shape. So if I look at them, back over here, I know that across the bottom, it is going to be 8 long, and we see that from here in the middle, and then I have arrows that tell me that it is 2 wide. So when I fill in my pieces, my base is 8, my height is 2, and then I'm still multiplying times the other 2. So when we multiply, we get 16 times 2. And remember, you can multiply in whatever order, which gives me 32. Okay, and we are talking in inches squared. So my green area is 32 inches squared. Now I'm going to do the same thing with my red pieces. So my red over here, if you look on this side, okay, it's going to be 11 inches tall. So again, area equals base times height times 2. My base is 11, my height is 2. And then I'm still multiplying by the extra 2 because there are 2 sides that are the same. So I'm going to switch up the way I multiply, so 11 times 4. So I get a total of 44 square inches for my red pieces. So we have one more last piece, and that's going to be our blue pieces. So blue is in the middle. Again, same formula, base times height times 2. The base of the big rectangles in the middle is 8. The height is 11. And times 2. So 88 times 2. So I'm going to come over here and multiply that. So I have 16, 17. So I get 176 square inches. Now, those numbers individually do not help me. So to find the total area, remember I said all the sides plus the bases. So I'm going to add all 3 of these numbers up. Okay, I'm going to come over here and do it over here on the side. So I have 32, I have my 44, and I have my 176. So I have 6, so that's 12. Carry the 1, 7, 14, 15. Carry the 2, 1. So 252 inches squared is going to be your final answer for this problem. That is how much cardboard it takes to unfold this 3D shape and make the entire piece covered.
Okay, our next example, we have a clear plastic container shown below. It is used for storage, but Sarah wants to cover the lateral surface area with material to make it more appealing visually while leaving the ends clear so she can see what is in the container. How many square inches of material will she need? Okay, so remember up here when Ms. Nelson talked about lateral surface area, that is just the sides. That means we want the bases we are not including the bases. So when you look at this this prism, the 3D figure, we see our bases are triangles. These are the 2 bases. This is called a triangular prism. We do not want to include those. We just want to include the sides. So look over here where we have it all unfolded, the net. So here's the bases, but we do not want those included. But we're going to go ahead and mark them. So when we're looking at our measurements, we need the information on those bases. So all we're getting is the B, C, and D. So we're getting the 3 rectangles. So what do we notice? We only the bases are the same. And those are the triangles, right? Each of these rectangles have a different measurement. So we're going to use our net to figure out what those measurements are. So looking back over here on our prism, this short end of the triangle is 5 inches. So let's go over here and look at the short end of the triangle. That is right there. So we know that this measurement, when you fold it up, folds up on this measurement, and so that is 5 inches. So now let's look on the other side. We know the other leg that is attached to the right angle on the triangle is 12 inches. So here's the other leg over here that's attached. When you fold that up, it's going to fold up on this side. And so we know that that is 12 inches. Now on the bottom, these are the same. Because remember we said that the 2 bases had the same measurements. And likewise, these fold up on each other when you fold it up. So you have to envision what it's going to look like when you fold that up. So this measurement here, though, this third leg, the long side, if you look up here, this is 13 inches. Now we have to see how wide, now that we know the bases of our rectangles, we need to know how long it is. And so that is this line here, the long side of the rectangles, and that is 18 inches. So now we have all the measurements on our net, and so it's easy for us to go ahead and find our surface area. So we're looking for surface area, and we want lateral, and I always put a little L there, just to remind myself. Okay, so the way we're going to do that is we're going to find the area of B plus the area of C plus the area of D. And it's already labeled for us. So I'm just going to come over here and do B. We know that area of a rectangle is base times height. So B is 5 times 18. And I'm going to come down here and do 18 times 5. So that is 90 square inches. And I usually circle, just a little strategy I use when I know I'm going to have to add that later so I don't have to go hunting around my paper for it. I just put a little circle around it. Okay, so now I'm going to do C. Again, we have the same formula, area equals base times height, and that is going to be 13 times 18. So I'm going to come down here. So that is 234 inches squared. Let's put it there. And now we're going to do another color. D. Area equals base times height. 12 times 18. So area equals 216 square inches. So let's look back up at our formula up here. We need to add for surface area. We're going to add those three together. So we have 234 plus 216 plus 90. That's a 0, by the way. So our surface area, our lateral surface area is 540 square inches. Okay, so you can see these really aren't difficult. They're just a little tedious. Now I'm going to have to erase down here so we can answer this extension question. So I'm just going to make some room for myself. And it says, now find the amount of material needed to cover all sides of the container. Now, so if we're covering all sides, we want total surface area. So we're going to do area of B plus area of C plus area of D, and then we want area of A and area of E. Now, we said earlier that A and E, those two triangles, have the same measurement. So all we have to do is take our lateral surface area that we've already figured out and add those two triangles. So my area of A, I'm just going to do A, and well, A and E. And we know area of a triangle is 1/2 base times height. Now, but we want two of them because we want A and E, so we're going to multiply that by 2. What happens here is this 2 times 1/2 ends up being 1. So our formula for the two triangles is just base times height. And our base is 5, and our height is 12. So remember, when you do base and height, it's always where the right triangle, the right angle is, the little square. It's those two legs that connect those. Okay, so we know 5 times 12 is 60. Take our original lateral surface area plus the two bases makes our total surface area 600 square inches is our total surface area. Whew.
Sorry. Okay. So again, guys, these are not hard. These are like your composite shapes. They take a lot of time because you have to break everything up. Okay. So on your next page, it says name the polyhedrons shown. All of these shapes are called polyhedrons. But whenever we talk about naming a shape, we name them for the shape of their bases. Okay. So if we look at this shape, you see that this comes to a point up here. So I know it is a pyramid. And to know what type of pyramid it is, I look at the base. The base is in red over here on the right. So this is a triangular pyramid. You cannot just say pyramid. Now that we are in 7th grade, things are not just pyramids. We call pyramids specifically for the shape of their base. So it says, notice how the measurements on the 3D shape relate to the net. So, like here, on my base, my side is 6. So over here, my side is still 6 on the base, and so on. Okay? So, will any shapes have the same area? So when we come over here and we look at our sides, it looks like that all the heights of my sides, okay, of my pyramid are going to be 8 feet. The base of all of them are going to be 6 feet, and that 5.2 is specifically pointing to the height of my base. So the shapes that are going to be the same are going to be the 3 sides. And I'm going to make a note that these 3 sides are going to be triangles because that affects how I'm going to find the area. So lateral surface area means just the sides. So I know that my sides are triangles, so area is going to equal 1/2 base times height. But because we are dealing with a triangular pyramid, to count how many sides I have, you count the sides of your bases. So 1, 2, 3. So I'm going to add a times 3 because all of these sides are going to be the same in this example. It may not be that way for all of them, but in this particular example, all are the same. So when I fill in 1/2, the base of my sides, okay, we had circled was 6. The height was 8, and then I'm still going to multiply by that 3. So I'm going to do the same thing that Ms. Holt did earlier. I'm getting rid of my 1/2. I'm going to cancel my 1/2 with my 6, and that's going to become a 3. So now I have 3 times 8 times 3. I'm going to group it as 9 times 8, which gives me 72, and we are in feet squared. Okay? So the lateral surface area is 72 feet squared. So when we move over here to the right for total, we know that to find total surface area, it's the sides plus the base or bases. In this case, we only have one base because it is a pyramid. A pyramid can only stand on one side. It can't stand on the point. So, and I know that my sides, we've already done half the work for this problem. I know that my sides are 72. Okay, so to find the base, I know that my base is a triangle. So it's still half BH, and there's only one of them, so I don't have an additional number to multiply by. So I'm going to substitute in 1/2. My base is still 6, but now my height is that 5.2 that we haven't used yet. Okay? So I'm going to get rid of my half. Half of 6 is 3. So now I'm going to multiply 5.2 times 3. And you get 15.6. So I have to plug that back in up here. So now I need to add them. 72 plus 15.6. Notice that I added a decimal and a 0 behind my 72. I did not line my 2 up with my 6. That is a big mistake that we keep seeing a lot of you making over and over. You have got to make sure you line up your decimals. If a decimal is not shown, then the decimal is at the very end of the number. So I'm going to put my decimal, I'm going to add 6, 7. So my total surface area is 87 6/10 feet squared.
Okay, so name the shape below. If you fold that up, that is going to be a rectangular pyramid. Anytime we see that the sides are triangular, we know it's going to be a pyramid. And you go by the base, and with pyramids, the base is where there's only one of, and so that would be in the middle there. So we have a rectangular pyramid. All right. Will any shapes have the same area? So we know that the base will, there's only one base, but when we look, this is 8 centimeters wide. The corresponding side over here is 8. So these opposite triangles will have the same area. Likewise, these ones that are opposite here will have the same area. Okay, so will they have the same area? Yes. Opposite triangles, which are the sides of this pyramid. Okay, lateral surface area. Remember, lateral is just the sides minus the base, and so we're going to add, so I have surface area. Lateral is going to be blue triangle plus the green triangle, the areas of the blue and the green triangle. So let's come down here and we're going to do blue. And again, our formula for area of a triangle is 1/2 base times height. But remember, we have 2 of those, so we're going to have to multiply that by 2. So just like Ms. Nelson did and I did before, this 2 times 1/2 becomes 1. So now all we have is base times height. Our base for the blue is this 8 centimeters. Our height is this 14 that goes up there. And if you notice, the bases will be different on the 2 triangles, but the heights are different too. Okay, so 8 times 14. So area of our blue is 112 square centimeters. I'm going to circle that because I'm going to need that in a minute. Now I'm doing the area of my green, and I'm actually going to use green instead of a different color. So we already know, looking back over here, since we have 2, it's actually for the 2, it's just going to be base times height. So our base of the green is 6, our height is 12, there's your height there. I know 6 times 12 is 72 centimeters squared. Now, we have to add those 2 together. Remember up here when we talked about it, blue, the area of the blue plus the area of green. So we have 112 plus 72. So our lateral surface area, and I always like to put a little L there, 184 square centimeters. Okay, so now it asks us for the total surface area, and we know our total surface area is this lateral, right? 184 plus our base. Our base is a rectangle. And so that is going to be base times height. right today or something. Trying to hurry because I know this is long. 184 plus 6 times 8. $184 plus 48 is 232 square centimeters, and that is your total surface area. Okay, if you have any questions, come tomorrow.
Hi.